Hello, this is Mr. Stansbury. I'm going to take you through the notes on determining the variation model. Okay, at the end of this, you should be able to say, I can determine which variation model to use with related variables. Okay, so first thing first, there are different variation models. If y equals ax to the nth power, where n is an element of the integers. So basically this is just some, 0, 1, 2, 3, -1, -2. And n does not equal 0, okay, because that's just going to be y equals a, and that's not going to help us too much. Then if n is greater than 0, 1, which would be 1, 2, 3, 4, 5, so forth and so on, it's considered direct variation. So for example, if it's 1, here's y equals ax to the first. Here's y equals ax squared. Here's y equals ax cubed, so forth and so on. If n is less than 0, so that would be -1, -2, -3, it's considered to be inverse variation. Okay, so there's y equals a over x, because if you'll remember from before, ax to the negative first is the same thing as a over x. Okay, so that would be this yellow one, and then y equals ax squared would be this green one, the turquoise one, and then y equals a over x cubed would be this pink one here. Okay, so those are just kind of general ideas here to kind of help you understand what's going on here with this, and this would be similar to example 7. The volume V of a sphere is directly proportional to the cube of its radius r. Okay, so let's write ourselves a little direct variation. So we know that the volume is directly proportional to the cube of the radius r. So that's going to be r cubed, right? But there's going to be some kind of variation constant here, right? But we don't need that constant in there. But V volume varies directly to r cubed. All right, now the graph is shown. Find the equation of the variation model. Okay, so what we want to do here with this is we've got a point here. So we know that when r is 2, our volume is going to equal 33.5. Okay, so what we want to do, this here kind of tells us how to set it up. So really what this means is our volume is going to equal some variation constant k times r cubed. Okay, that's what this means. Okay, so now what we want to do is just plug in our info in here, and that should actually help us figure out what k is. Find the equation of the variation model. So we need k. We know what, we leave v and r, but we need to figure out what k is. Okay, so V in this case is 33.5 equals k. We don't know yet, but we do know that r is 2. So we're just going to take that 2 and we're going to cube it. So we get 33.5 equals 8k. Divide both sides by 8. And we get that k equals, let's see, 33.5. Oops, that is not it. I missed a 3. 33.5 divide by 8, and we get 4.1875. That is going to be our k. Okay, so then that means the equation of the variation model would be volume is going to equal 4.1875 times r cubed, and that's our model. So all we need to do is if you know r, you plug in r and you can figure out what the volume is. If you know what the volume is, you plug that in for v and you can figure out what the r is. Okay? Okay. Now, just to kind of help you understand this one a little bit, the actual volume formula for a sphere is volume equals 4/3 pi r cubed. Okay? So if you actually take this in the calculator, we take 4 divided by 3 and multiply it by pi. Guess what we get? 4.188. It's a little bit off, but we had to round this number off here. Okay, so that's what that 4.1875 is. That's the 4/3 pi. In case you are somewhat familiar with the volume formula of a sphere. Okay. Let's take a look at another example. But before we do that, let's take a quick little comedy break.
Come on, Lola. Come. Okay, come here. You can do it. Come.
Whoa, check out his teeth, guys.
Yeah, it's not. He's not in the fight.
You see the nose right there? Whoa! Jeez.
I told you.
Wow. All right. All right. Example. It is suspected that y varies inversely with x squared. Okay, before I even answer any of these questions, let's write ourselves a direct variation. Okay, so if it varies inversely with x squared, we know that y would then vary directly with 1 over x squared, right? Because that is the inverse of x squared. Okay, so that's our little direct variation equation. Well, not equation, but statement there. Okay. Does the graph seem to support this claim? So does that look like the 1 over x squared? Sure, it's got the same shape. Yes, that seems to support it. If you were trying to say that this is y equals x squared, that would not support that. So, but this is obviously some kind of inverse variation. We can't tell exactly just by taking a glance at the graph as to what power it's going to be, but it does at least seem to support that. Okay, state the equation of the model connecting y and x. So the big key in here is we want to at least be able to find one point, and there's one point at 1 and 5. Okay, so with that, we know that when x is 1, y is going to be 5. So we can plug that into this here. Again, this isn't our equation, but from this direct variation statement here, we can say y equals k times 1 over x squared, right? If it varies directly, it's always going to have some kind of constant out there multiplied by this 1 over x squared. So now we just plug information in. So y is 5. We don't know what k is. That's what's going to help us write the equation of the model. And then we have 1 over, in this case, it's just 1 squared, right? So that's going to be 5 equals 1 over 1 squared is just 1. So 5 equals k. So that means the equation of the model is going to be y equals 5 times 1 over x squared. And you can just leave it like that. That's totally fine. You could write it as 5 over x squared if you want, but this is totally fine. Okay, so then find y when x equals 0.5. So now we can just take this 0.5, plug it in for x, and see what we get for y, right? So y equals 5 times 1 over 0.5 squared. So that's going to be 1 over 0.5 squared is 1 over 0.25. Okay, so really that's, you could go through and multiply this 5 divided by 0.25, or you could say, hey, wait, 1 over 0.25, that's 1 over 1/4. So if you flip this 1/4 over, it's really y equals 5 times 4 over 1. Okay, so y in this case is just going to equal 20. If you take 5 and divide it by 0.25, you're going to get 20 there as well. Okay, so y would be 20 when x is 0.5. And if you double check on here, here's 0.5. So if we go up here, there's 15. So way up right about here at 20, this is going to be 0.5 and 20 right there. Okay, so that looks like that at least matches up with what the graph is showing us there. Okay, that's all we have for determining the variation model. If you have any further questions, please feel free to ask. Thanks.